Hello everyone, welcome back. So in the previous video we had done about the exercise, a few questions and a few identities were done. Now we'll move ahead with the next identity. The next identity is a square identity, that is a plus b plus c whole squared is equal to a squared plus b squared plus c squared plus 2ab plus 2bc and plus 2ca. So this is the next identity, and first we'll understand the use of this, how to use it, and then how to use it in factorizing. There are two parts. One is in expanding and second is in factorizing. So we'll do both one by one. First let us take in expanding. Suppose you need to expand 2a plus 3b plus c whole square. Suppose you are asked to evaluate this, to expand it. Now in this case, what you will do is, we will use this identity, and if you compare it, you find that in the identity it says a, whereas in the question it says 2a. In identity, the b in question, it is 3b. In identity it is C, and in the question also it is C. So what we have to do, in the identity, the right side, we will replace A with 2A, B with 3B, and C, of course, it will remain as C only. So using it, if you try to expand A squared, it will be written as square of 2A plus B squared, it will be written as square of 3b, then plus c squared, it will be written as square of c, and then plus 2ab, that is 2 multiply 2a multiply 3b, because a has to be replaced with 2a and b has to be replaced with 3b, then plus 2bc. So 2 multiply 3b multiply c, and the next says 2ca. So that is 2 multiplied by c multiplied by 2a. And now this is what we have to write by solving it. So square of 2a, it is 4a squared. Square of 3b is 9b squared. Square of c is c squared. Then plus 2 multiply 2a multiply 3b. So 2 into 2 is 4. 4 into 3 is 12. So it is 12ab. Then plus 2 into 3b into c. 2 3s are 6. Multiply b into c. So 6bc. And then plus 2c and 2a. These three, when you multiply, you get 4ca. So this is the expanded form. Let's have one more example. It will be more clear to you. Suppose you are given 2x, say minus y and minus 4z whole squared. Now here, when you have it in this form, 2x minus y minus 4z whole squared. Now this form and the left hand side of the identity, if you compare, identity, it has plus sign in between, whereas this question which is given to you, now it has minus sign here. So what we will do is, you can rewrite it in the form 2x plus minus y plus minus 4z and then the whole square. What we have done? We have tried to write it in the form of identity. Now you use the identity that is a plus b plus c whole squared equals to a squared plus b squared plus c squared plus 2ab plus 2bc and plus 2ca. Now if you use this identity and compare it, what do you find? The a in identity is equal to 2x in the question, b in the identity is equal to minus y in the question, c in the identity is equal to minus 4z in the question. So here now comparing it, square of a means square of 2x plus square of b, it means it is square of minus y plus square of c, that is square of minus 4z, then plus 2ab, twice the product of a into b. So what is a? It is 2x, multiply b, it is minus y now, b is minus y, then plus 2 multiply b into c. Now what is b here? B is minus y, and what is c? C is minus 4z, then plus 2ca. So c is minus 4z, and what about a? A is 2x. So after writing this, now we try to simplify it further. So if you simplify this now, the square of 2x is 4x squared, square of minus y is y squared, plus square of minus 4z. Now when you take the square of minus 4z, it is 16z squared. Then 2 multiply 2x multiply minus y. Now 2 multiply 2 is 4, and 2 multiply 2x, if you are taking, it is 4x. Then 4x multiplied by minus y, it gives you minus 4y. So here you will have minus 4xy. Then next 2 multiply minus y is minus 2y, and minus 2y when multiplied by minus 4z, this will become plus 8yz, because minus into minus, this will become plus. So plus 8yz. Then you have 2 multiply minus 4z multiply 2x. So when you are multiplying these two, 2 into minus 4 is minus 8, minus 8 multiplied by 2, it is minus 16. So you will have here minus 16 zx. So this is the expanded form. So this is how you are going to use the identity to expand the given, say, binomials, polynomials. Now next we will try to understand the use of it in factorizing. How to use it in factorizing the equations given. Now suppose you are given a polynomial, not equations, it is polynomials. Suppose you have a polynomial, say 4x squared plus y squared plus z squared, then minus 4xy minus 2yz and plus 4xz. Now if suppose you need to factorize this expression. Now here if you see, first thing is there are total 6 terms, and our identity which we have done, that also has 6 terms on the right hand side. Out of those 6 terms, 3 terms, they are perfect squares. So here if you see 4x squared, y squared and z squared, they are 3 perfect squares. Now 4x squared, it is square of 2x plus y squared is square of y plus z square is square of z. Now the remaining three parts, what it is? 2ab, it is twice the product of a and b, then twice the product of b and c, then twice the product of c and a. So if you see 4xy, this part, if you see this term, if you are taking 4xy, it is twice the product of 2x and y. So you can write 4xy as 2 multiply 2x multiply y, because 2 into 2x plus into y gives you 4xy. Then 2yz. Now 2yz, if you see, it is twice the product of y and z. It is twice the product of y and z. Then you have 4xz. Now this 4xz is twice the product of z and 2x. Is it clear? But now here what we have to do, in the identity we have all these terms positive. All the terms are positive. So we will have to put a sign of plus. We need a sign of plus here. But in the polynomial given, if you see, the last term is positive. So this does not make any difference. But these two terms, they are negative. Now if you check out these two terms, that is 4xy and 2yz, let us check it here in the factors now. 2 into 2x into y and 2 into y into z. Here, out of these factors, there is a common factor, that is y. There is a common factor y in both the terms, and both these terms are negative. So what we will do is, we will put this common factor y as negative. Now if we just take this y as negative, you can see that the product becomes negative. So you will get minus 4xy. Here also the product will be negative, that is minus 2yz, and this product will not be affected because this does not have anywhere y in this. Is it clear? Now one more thing, here this part, this term is also having y. So what we will do? We will put minus sign here also. And putting this minus sign here will again make no difference. Reason being, square of negative value will always be positive. So that will give you a positive y squared. Now we have converted it in the form of identity. And once we have converted it into the form of identity, now we are going to use the identity, that is using a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca is equal to a plus b plus c whole squared. Now we are going to use it in the opposite way. So we are having this left part now, all the 6 terms from the identity we have it, and if you compare them, a gives 2x, b is minus y and c is z. So what will this be equal to now? A plus b plus c whole square. So what is a? 2x plus what is b? Minus y plus what is c? Z, and it is the whole square of it. So what do you get? You get 2x minus y plus z whole square. So these are the factors of this expression, if this polynomial given to us. Or you can even write it as 2x minus y plus z multiply 2x minus y plus z. These are the two factors. Now in this, sometimes you get such a expression or such a term where you will be unable to convert it into form of squares. For example, say you get somewhere 2x squared. Now if it is 2x squared, how will you write it in the form of whole square? Can you write it in the form of whole square? Because x squared, this is a perfect square, it will be square of x. But what about 2? Can it be converted into whole squared? It can be converted into whole squared. You have studied about the irrational numbers now. So under root 2 is square of under root 2, because under root 2 multiply under root 2, you know that it is equal to 2. So 2x squared can also be converted into whole square as under root 2x. Now instead of 2x square, if suppose you have 8x squared, then how will you convert it into the form of whole squared? Simple, if it is, you will say that it is under root 8x whole squared. Okay, on the same pattern, if you continue, this is what you get. But you can also write it as 2 under root 2x whole squared. It can also be written as 2 under root 2 whole squared. And why it is so? Because if you check it out, 2 under root 2 when multiplied by 2 under root 2, what do you get? 2 multiplied 2 is 4, and then under root 2 multiply under root 2 is 2. So 4 into 2 gives you 8. So in this way, you can also write under root 8 as 2 under root 2 whole square. So this is one part, and based on this, you have your question from the exercise, that is question 4 and question 5. From your exercise 2.5, you have question 4 and 5 based on this identity. So it will be helpful for you to solve this. So try out these two questions, and meanwhile I'll just explain you one more identity, that is a cubic identity. These are new to you, that is a plus b whole cube, and you have a minus b whole cube. Now these two identities are there. The use of them will be the same as you have done the square identities, that is a plus b whole squared and a minus b whole squared. I'll just tell you what are these equal to. A plus b whole cubed is equal to a cubed plus 3ab multiply a plus b plus b cube, and a minus b whole cubed is a cubed minus 3ab multiply a minus b and minus b cube. These are the two cubic identities. This same part can also be written in another way. Now a cubed will be kept as it is, whereas this middle part 3ab multiply a plus b, this we will write it as 3a squared b, because 3ab multiply a will give you 3a squared b, and 3ab multiplied by b will give you 3ab squared and plus b cube. So it can be written in any of the two forms. Similarly, a minus b whole cube again can be rewritten a cubed as a cubed itself, but minus 3ab when multiplied by a, it gives you minus 3a squared b, and minus 3ab when it is multiplied by minus b, it gives you plus 3ab squared and then minus b cube. So these are the two identities, and use of them same as a minus b whole squared you have done. If suppose you need to find out 2x plus y whole cube, you need the expansion of this. If suppose you want to find out the expanded value of 2x plus y whole cube. Now in this case you are going to use a plus b whole cube. If it had been 2x minus y whole cube, then you would have used a minus b whole cube. Now how to use it, that I'll explain you. You are going to use here a plus b whole cube, and this is the best part to use when you are writing it in the expanded form. That is a cube plus 3a squared b plus 3ab squared and plus b cube. Now if you use this, the value of a in the identity will be replaced with 2x. The value of b in the identity will be replaced with y. So what do you get here? A cubed, it is cube of 2x plus 3 multiply a squared, that is square of 2x multiply b, that is y, and then plus 3ab squared, 3 multiply 2x multiply square of y, and plus b cube, this is cube of y. So this is what you get. Now you can expand it. Cube of 2x is 8x cube plus 3 multiply square of 2x is 4x squared multiply y plus 3 multiply 2x multiply square of y, that is y squared, and plus cube of y is y cube. So the final expanded form will be 8x cube plus, now when you multiply these you get 12x squared y plus, when you multiply these you get 6x y squared and plus y cube. So this is how you can use this identity to find the expanding form, or while solving this polynomial in the cubical form. Same way you can even use it for finding the cube of numbers. Now suppose if you are somewhere asked what is cube of 105, what you will do? You can write it as 100 plus 5 whole cube and then use the same identity. If you are somewhere given to find say cube of 98, then it is better you write it as 100 minus 2 whole cubed. And when you write it in the form of 100 minus 2 whole cube, which identity you are going to use? A minus b whole cubed equals to a cube minus 3a squared b plus 3ab squared and minus b cube, where a is 100 and b is 2. So you can just solve it. If you want, let me explain you, show you how it will be. A cube, it becomes 100 cube minus 3 multiply square of 100 multiply 2 plus 3 multiply 100 multiply square of 2 and minus cube of 2. So what is cube of 100? It will be 100 multiply 100 multiply 100, that is 10 lakh. minus, now square of 100 is 10,000. 10,000 when multiplied by 3 and multiplied by 6, you will get 60,000 plus 3 into 100 is 300 multiplied by square of 2. Square of 2 is 4. So 300 multiplied 4, it is 1200, and minus cube of 2 is 8. So 10 lakh and plus 1200. If you are adding them, you get it like this. 10 lakh 1200 minus 60,000 and minus 8. This will give you minus 60,008. Now subtract these two. On subtracting these two, you will get the cube of 98. So 10 minus 8 gives you 2, 9 here, here it is 1, here it is 1, then here you are going to get 4 and 9. So you have it 9,41,192. So this is for today, and based on this cubic identities, you can even complete the question number 6 and 7. So overall, your homework is exercise 2.5 question. You will complete with 4, 5, 6 and 7. 4 to 7. These questions can be done based on this part which I have explained it. So we'll meet again. Till then, have a nice day. Thank you all. Jai Hind.